Okay, what we're looking this time is the idea of surds, which is part of dealing with surds and indices, but we'll really concentrate on surds to start off with. Before we look at what a surd is, and there's our surds there, it's in the irrational numbers, what we want to do is make sure we understand what rational numbers, irrational numbers are. So remember our definition of a rational number, and rational numbers are integers, fractions, finite decimals, or recurring decimals. So if you remember what an integer was, 1, 2, 5, 100, 1,000, and 20. They're all integers. They're whole numbers. We know what a fraction is. Okay, we've done plenty of those. Finite terminating decimals. Okay, decimals that stop, and we can start to put that over either tens or hundreds or thousands or so on, depending on our place value, or recurring decimals. So you look at recurring decimals. And remember, we had ways earlier on in the year that we were able to convert those into fractions. So all those can be both put down to fractions in that term. And really, that's what a rational number is. If we remember our definition of a rational number, it's any number that can be expressed as a fraction. So, or any number that can be put in the form a over b, where a and b are integers or whole numbers. So we're going to get a rational number if we can do that. So all those numbers come down to being fractions. These numbers, however, cannot be in fractions. And what ones are we talking about? Anything that's an infinite or non-recurring decimal. So decimals that went on forever and didn't stop, didn't have any places where they stopped, and they didn't have any pattern. Then they were irrational. They're irrational numbers. It's got a pattern and it recurs. It's definitely a rational number. Surds, okay, what are we talking about surds there? Something like square root of 2, square root of 5, anything like that. 101, they're going to be irrational numbers. We've seen pi and e, and we know that they are numbers that never stop, don't have patterns, so we know they're going to be irrational as well. We've talked about that. But the surds are the main important ones. It's where we've got this radical sign. So what we've got to be careful of is we get ones, because any time we get the square root of some number, it's going to be some decimal place and keep going on forever. So it's going to be a non-recurring decimal. What won't be a surd would be one like that. Square root of 4, that's going to give us 2. Well, that goes into that category because it's going to be a rational number. Gives us 2. So what we're looking at with surds is that a situation where you're going to take the square root of a number and it's going to be a number that is not a perfect square. You get something that's not a perfect square, that's going to be, and it's going to be something that's going to give you a decimal, and it's going to go on forever. So if it is a perfect square, well, you take the square root of it, and it's going to be a whole number then. So it's going to be part of the rational numbers, not an irrational number. So that's what a surd is. Surd is basically taking the square root of a number, and that number is going to be a non-perfect square. So, and the idea of perfect squares are going to be important as we go through and do a lot of this work. So keep them in mind.